Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Building custom agents and chains with open source large language model like Alpaca-Lora on Google Colab. You might be wondering, why should we create agents and chains that is depending on open source LLM? First and foremost, the reason is that the agents and chains that are created right now inside the Langchain library depends on OpenAI. So let me show that to you immediately so that you will understand. Let us come to this a little later. Let us go to the Langchain hub. Langchain hub is a place where you can find the various chains, prompts, and the agents that is used. Sorry, I think there is an internet issue. Just give me a moment. Yeah, it is coming back, and you'll see that we have agents, chains, and prompts. So let us go into agents. I had discussed about this in the earlier video also, but now we are going to go a step ahead and we are going to create the agents with LLM. So before that, I wanted to show you this. So let us go into zero self-ask with search, and if you click on agents.json, you will actually see that there is a template. So it's a zero-shot agent template that has been created, and it is actually using a lot of questions here, question and answer type of a setup, and this is actually an example prompt that has been given. If you are aware of the various prompt techniques that is available in large language in Langchain library, this is one of the options. This is actually an example prompt that has been given, how to think. Okay, and then the model that is getting used is TextDaVinci 003, and the max tokens, all etc. We can see that here, and we can see the output finally that it is self-ask with search. The target for me here is to create the same agent but with open source model here, and also with a different type of pipeline here. This is the actual target that I fixed myself this time for this video. Okay, I will actually zoom in a bit so that you guys can see it better. So I was talking about this particular prompt, and I was talking about this model 003, and I was talking about this type of the LLM. So we are going to change this right now. So let us go back to the presentation. This kind of trying out the open source LLM is little challenging also. It's not something that it's not something that we have to program. It is already available there. Only you have to take those LLMs, try out whether they work with large language models object that Langchain can use. Okay, so that is one of the challenges I was facing, and then I felt, okay, let me share it with you guys so that if you also face this problem, you can also come up with new solutions. So that's the main intention. This is whatever I am presenting is just scratching the top of what is possible. So you'll see that in couple of minutes. The challenge is, as I was explaining, that we need to have an LLM that is at least equal or better than TextDaVinci 003. We are not comparing GPT 3.5 or 4. Okay, those things will come later for sure, but at that time we need to be ready, right? And this is also one of those videos where you understand how to use those large language models and to create various agents and tools for your benefit. And we see that we have to convert the LLM whichever is available in open source into Langchain readable object, and the output has to meet the prompt templates that is inside Langchain library. As I showed you already, the existing library all depends on OpenAI. So most of the agents that we call, if you are going to call just a minute, let me actually go back. If you are going to call any of the agents, so if I come here and if I call any of the agents like zero shot React conversation, zero shot React description, if you go into that, you will again see that this agent is created based on TextDaVinci. Okay, this is actually a basic agent which does not depend on anybody. So you see that this is a basic agent with input and agent scratchpad. So this is a very this agent you can also use very freely. So load from LLM and tools. So this we can use very freely. And if I go back to the React SQL, let us see the React SQL. I was exploring these things in today morning. So this is also, so here it is purely prompt. Agent is based on prompts, and that is how it has been created. So we will create similar things in coming in this video also. Let us go back to the PDF again. And finally, the objective is to have an output that should be safe for consumption and also should be useful also. The safe for consumption can be done by constitutional and moderation LLM already available. We can also look at the templates, and then we can build. Currently, what we are going to do is, we are going to try to work with one of the Alpaca-Lora LLM that is available out there, which actually gives some pretty neat, decent response. It's not awesome, but it gives a pretty decent response. It works with most of the prompts that we provide. So that is why I wanted to try it and show it to you guys. The chains are made of LLMs and tools. So chains are basically the workhorses, while the agents are the orchestrators or prompts that push the LLMs. We build it in the usual fashion. There's not much of a difference, and then we serialize the output as JSON. So you will see that in action in this particular notebook. I will be sharing that with you guys. The main intention of giving this making these videos for you guys to practice it. I hope that you understand the reason why I'm making this. So try out your options, try out your ideas on these notebooks, and do share it with others, and do subscribe to the channel for further updates to your YouTube dashboard directly on not just Langchain but also the surrounding ecosystem in large language models. Let us go to the browser now. Let us head to the agents and chain. This particular notebook will be shared in this GitHub repo. This particular link also will be shared with you guys, so you can take it from there. The initial step up to creating the basic LLM chain. Go down up to creating the basic LLM LoRa, up to the basic LoRa underscore LLM model, the large language model based on Langchain. Till this I have already covered in the earlier videos also. A couple of videos I have already discussed. I am not going to discuss this again. This particular notebook has to be GPU enabled. So this is already using a GPU of almost 9 GB, and you can just change it here. Change the runtime, you will get the GPU option. You will be given a couple of hours, not more. So use it wisely, and you can actually check the type. From here, what we are going to do is we are going to start working on the working with the LoRa LLM. We are not having any of the OpenAI LLM here. We are only using the Alpaca LLM, that is Alpaca-Lora LLM. Got it? LoRa is actually low ranking fine-tuning technique that has been used. So if you are new to all these things, I will share the link for earlier videos that I had made on those topics. You can get a good understanding about that. Here I have already created a basic prompt where I give a question and I ask it to think step by step, and then I give it a question. So let me change the question. So let me ask, okay, let me ask something that it can think. How many fish can live in an ocean that is as big as America? Or let us be more specific, North America. Okay, let me execute this and let us see how the output comes, because we are not using TextDaVinci, we are using Alpaca-Lora. Let us see how the output comes, because this actually matters. You will see that it's not what we expect. It is okay. It's not the best output, but we start getting the output that is coherent and readable also. It will take some time. In the meantime, I will explain the serialization process. This particular chain that we have created, we can actually save it as JSON file. And okay, so here we see the first ocean is not a single body of water but a collection of water bodies. it is actually completely going tangential. It is nowhere even touching North America, okay, and it is giving an answer which is actually not what we requested also. So this is, you can find that it is totally odd, right? The reason is that how we initiated it. So the max tokens that we can get is actually 100. Okay, the way the pipeline has been created is only for 100. If you try to increase this token, the time that it is that it takes to explore to calculate is more in this environment. So that is why I kept it at a very low level. So you can play with this. Don't increase it to 1000 or 2000. It will not complete at all. Okay, and moreover, this pipeline text is not meant for text generation, but still you see that it is actually telling, it is giving various other models that you can use, but not this. But still the answer is still out there. You can actually explore these models also and try it out. Also remember, these models are not directly these models we cannot directly load into the GPUs that easily. So you will need a very huge GPU for some of the models. Be careful when you are loading, or else after all, your Colab notebook will crash, because if the GPU memory gets exceeded, your Colab memory will crash. And if you are going to try some other model, ensure that you actually restart the notebook and don't execute this particular step. If you execute this, what will happen? This will load the model into GPU. So this step will load the model into GPU. So after this, if you again load a new model, what will happen is it will immediately crash. So don't try that. So that's why I'm just giving you a heads up to work with this. Anyway, so we have got an output which is coherent to read, but it's not correct. So as I was telling, the output is not usable, but it's fine. So we will see how is the JSON file. So if you take a look at the JSON file which is created here, let me actually move to a different move to the next pane. So if I move, so here if you take a look at it, you see the input variables. It is very similar to what we saw in the Langchain hub, right? And it has got the prompts, and here you see the model ID, the LLM. You see the model ID is different, llama 7 billion HF, and you see the Hugging Face pipeline in place of OpenAI. We have Hugging Face pipeline right now. This is what we were after. So we are able to create our own agents and our own chains using open source models. So you can also try that out. Next, what I am going to do is I am going to create a sequential chain. Remember, you cannot actually create the sequential chain into serialization. You cannot serialize it. So I will show that to you also. In all these chains, I am going to use LoRa only, the language model that I created, the LoRa _ LLM, and I'm just going to ask, okay, let us ask, okay, how big is, so I'm asking how big is London Bridge, okay, and I have actually asked, so the first chain is I'm telling that the model is an engineer, and the second chain I'm telling the model is a MBA from Harvard. Okay, the first one will give a synopsis, write a synopsis, and the second will review the synopsis. Okay, this is what is happening right now. So it is starting the simple sequential chain, and you see that it actually completed the entire discussion. So there is a synopsis that came forward, and after that we saw that it went into the second chain, which is actually shown here in yellow, and then we get the finish chain, but we did not actually get the review. You understood, right? This is what I was telling. The models are available, but still it is not matching to a level where we can get from OpenAI, but you can actually practice these things. That doesn't stop us. Yeah, the model is not up to the mark, but that doesn't stop us from practicing, right? That is the whole intention of this video. And if you try to save this overall chain, you cannot save it, so it will actually error out. So if you try to save this, and it will say that you cannot save the sequential chain, you will get an error. What we can do is, instead of actually you see the error, you will say that saving is not support for chain type. So you can close this. What you can do is you can actually create an agent with multiple steps, and you can actually save the agents. So now what we are going to do is we are going to work with SERP API wrapper, and we are going to use LLM match chain, and we are going to create tools, and we are going to initialize a new agent. We are going to initialize a new zero-shot agent, but this zero-shot agent will have LoRa as our LLM. Okay, you see the LoRa is actually the LLM, and then we are going to use we are initiating the agent, and agent can be saved, not the agent executor. Don't try to save the agent executor, it will not work. You can save the agent, and if you look at the agent, again, the agent will also have the Hugging Face model. And let us look how, okay, I am actually how to say, capping the iteration here. Ensure that you are also capping it, or else it will go on call your SERP API. If you are searching something, it will multiple times call your SERP API key. So be careful about that. So I am just asking how many people live in Canada. I got the answer, but now here I am asking how many people live in Canada as of 2023, and then divide the result. So let me execute this in front of you. It will go into the execution chain. As it is getting executed, I will also show you the custom agent that we created. So let it execute there, and by the meantime I will show it to you how it looks. So you see the input variables, and you will see the model ID and the Hugging Face pipeline. You can actually add the token numbers, etc. also here, and you can start working around that, like how you saw in the Hugging Face the Langchain hub. So you can create those things also, and you can practice these things. And you can also work with, okay, so whatever I am showing here, this is actually working with LLM. What is this called? LoRa LLM, but that doesn't mean that it will not work with OpenAI. It will work very well with OpenAI also. What I am trying to show is that that opposite, that we can use something that is apart from OpenAI also. That is the intention. And you see that the chain is actually going on. It is able to find the detail, but at the end of the day, when I am asking to go into the divide, the calculator chain, what is happening is that the answer is unable to properly execute. So you see the way it is getting printed out, we are asking for division, but it is not actually doing that. So the language model that is behind the agent is what actually orchestrating it. So where is the agent? So this agent is actually working with the prompt, and this prompt is working with the various tools, right? So if the LLM is not up to the mark, then all the rest of the tools are of no use. So, till the search wise it is okay, but after it goes to other tools, the existing LLM is the LoRa LLM is still not up to the mark. You can try it with OpenAI and see how it comes. You can, this is something that I tried. So how many humans will live on Mars by 2020? So I want to see how, what kind of reply comes. Each and every time different kinds of replies come out, depending on the search option it takes. So you can actually take a look at this also and experiment with it. Let us go back to the presentation. Yeah, it has come out. So it is searching right now, and here last time when you saw, it was actually it was saying only in thousands, but here now it is saying there will be 30 to 50,000 people there, and SpaceX will have the capability to transport this much. All these things it is getting from the internet only. And how many people will live on Mars by 2020 is the actual search key that it has used. So like this, you can actually practice basic things with Alpaca-Lora also. You see the answer is coming out. This is what I was trying to tell to you guys, that most of the things you can see, there are challenges. As I told you, there are challenges. It is not up to the mark of Text Da Vinci, but it can give you results that is actually readable. It is you can actually use it for coherent output. You can use it for practice. You can actually work on other prompts also. You can work on your prompt making capacity, and you can create agents, and you can fine tune it. All these things you can try it out with OpenAI libraries also, and also with these kinds of open source LLMs. And in future, when new LLMs come, just replace the LoRa LLM and start working with the a new LLM, and you will see rapid improvement in your outputs. So we can prepare for that ahead of time. So that is the overall intention of this video. I hope that you like it. Do subscribe to my channel for further updates on Langchain, transformers library, and various discussion around this ecosystem of large language model as well as on big data. So with this, guys, I would like to take the leave with, as usual, the 4 words: practice, guys. Practice, 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 practice. See you.